This Chapter 1 reviews quickly interest rate swaps, caps, and floors in preparation for their use in subsequent chapters. Our first worksheet, Pricing Grid, prices caps, floors, and further to the right, swaps on 3-month LIBOR with tenors ranging from 3 months out to 5 years in the case of the caps and floors, and strikes ranging from the 5% that you see here to further and further lower strikes that appear further down the worksheet as you click on page down. The LIBOR spot and forward curve is shown in this column D and is visibly quite steep in the present case, since LIBOR spot is 2.5%, whereas subsequent LIBORs are each 25 basis points higher, as you can see, reaching 7.25% after 20 quarters. You may also have noticed that to preserve space, we have had to hide a few rows between row 18 and 24. The notional amount used throughout this worksheet is $100 million. Next, we address an important but very tedious point regarding the discount factors that appear in this column G. Obviously, this number that you see here in cell G5, 1, cannot be the discount factor for any cash flow occurring anytime in the future. It is in fact the somewhat meaningless discount factor for a cash flow occurring right now. And it appears in the cell simply because the general form of the price formula for caplets and floorlets in these two columns, I and J, become easier if we insert this number 1 in G5. The number underneath the first discount factor and all numbers further down, those are discount factors for cash flows occurring at the end of the first quarter in G6 and thereafter at the end of each subsequent quarter. For the 20 consecutive caplets and floorlets that we are pricing on this worksheet, we do not need any other discount factors than these 20 DFs we have just highlighted. But for the 5-year swap, which is actually priced over here on the right, and specifically on row 17, which shows the different swap rates, and cell T17 for the 5-year swap, we in fact need, as you can see, one additional discount factor, and that's the one appearing in G25, and that is the reason why we have added this one discount factor here. If you decide to use this worksheet to price real-life instruments, please make sure you have thoroughly understood this very tedious point. Now, columns I and J, as we said a minute ago, reveal the prices of single period caplets and floorlets on 3-month LIBOR. So, for example, cell I17 indicates an upfront premium of $295,000 for the 5% strike caplet on 3-month LIBOR that will reset exactly 3 years from now, and for which you should note an implied forward LIBOR level of 5.5%, which indicates that this caplet is slightly in the money forward. To remind you, this means the implied LIBOR forward is higher than the strike for this caplet. Cell J17, right next to I17 that we just talked about, reveals for the floorlet of the same maturity an upfront premium of $185,000. And this is not surprisingly cheaper than the caplet, since the floorlet would be some 50 basis points out of the money forward, given that the forward rate is above. In this case, the strike makes it out of the money forward. Note finally throughout the worksheet the assumed annualized volatility in cell M6 of 30%. As you would expect, this steep LIBOR curve implies a number of realities that should not surprise you. First of all, in column I, caplets become rapidly more expensive as we go further out in time, since they become increasingly likely to be exercised, in addition to having a longer tenor. Two factors that increase the premium. Conversely, floorlets in column J generally seem to become cheaper as we go further out, principally because the diminishing intrinsic value of these in-the-money floors dominates the lengthening tenor, the second factor. Although if you go very far down in the worksheet towards where the floors are no longer in the money, then you will see this pattern beginning to reverse itself, and longer maturity floorlets becoming slightly more expensive, such as in those 3 cells highlighted here. Moving a little bit to the right in the worksheet, we see caps and floors whose prices are summarized in these tables starting at column O, exhibiting a similar but not identical pattern of prices. The caps generally become more expensive fairly quickly as we lengthen the maturity. The floors also become more expensive, but at nowhere near the same pace or speed, if you like, as the caps. We remind you that each cap and floor is constructed by stringing together a series of caplets or floorlets, as the case may be. This is best seen, for example, by opening the formula for the 3-year 5% cap right here and noting the summation of 12 individual caplets through the cross-reference to cells I5 to I16, which you can confirm in your own time are indeed the correct caplets. Finally, the swap curve in this row 17 is also quite steep given the steepness of the LIBOR spot and forward curve, but not as much as the LIBOR forward curve, since a swap, as you may recall, is a kind of average of LIBOR rates. You may have noted finally that for the sake of simplicity, this worksheet ignores the actual 360-day convention that would normally apply for dollar LIBOR and simply treats each quarter as spanning exactly 0.25 years in length. Both in this column C, you see this, but also in some of the formulas, such as the formulas for the discount factors, just to illustrate. And finally, we would like you to note the flat 30% vol that is used to all caplets and all floorlets, irrespective of their tenor or their strike, again done for the sake of simplicity, and very much in contrast with the reality of what is known as the volatility surface. We have completed the necessary review of swaps, caps, and floors, and can proceed to our construction and analysis of the more basic structured notes in Chapter 2.